Welcome everybody to this lesson on smart homes and energy efficiency as part of the Secove project. As we can see, data has shown that in the European Union, the 27% of the total energy is consumed by households. And the data also shows that in the US, the number is around 22%. Inside this number, looking at all the energy that our house consumes every day, between 50 and 70% of these energies is consumed by space heating and cooling, while just a number a little bit below are accounting for water heating and appliances. Considering this situation, appears evident that it's crucial to make our home more efficient. Now, given this context and this situation, we can look at set methods to reduce energy consumption. First of all, an important thing is to improve the building insulation in order to have major thermal efficiency to reduce in energy loss and heating and cooling cost. Besides that, it's important to adopt and buy efficient appliances that uses less power and optimize consumption. Finally, a helpful method to reduce energy consumption in our homes is to adopt automated heating and lighting with smart thermostats that can be adjusted based on occupancy conditions. Looking how smart homes automation can actually impact on energy savings, we can do some consideration. First of all, intelligent heating control. The adoption of intelligent heating control can help because it will set automated temperature based on occupancy and weather conditions. Secondly, the adoption of smart lighting system can help because sensor can adapt lights based on present detection and natural light availability. Finally, energy monitoring and management can actually optimize usage and help save energy. Because of this consideration, it appears obvious that smart energy management is fundamental in our homes and that automation can help us in doing so. First of all, the adoption of a smart automation control that help us to monitoring and controlling home energy use can help us actually save energy. Besides that, the adoption of smart meters and pricing data that actually adjust energy consumption based on real-time electricity prices. Finally, besides this, it's important to adopt specific energy saving strategies in order to optimize appliances and optimize the use of renewable resources for electricity. Which are actually these strategies in which we can smart manage energy in our homes? We have two different approaches. The first one is a user-oriented energy conservation approach in which the strategies are focused on the user. On the other side, we have appliances-oriented energy conservation approach in which the strategies are focused on the optimization of the appliance. First of all, let's look at the user-oriented energy conservation strategies. First of all, we have the user location detection, in which the system uses the user location to control appliances. Secondly, we have off-peak scheduling, in which the scheduling of appliances is set during low-cost off-peak hours. Then we have the adoption of meta-heuristic algorithms inside our system, in which these algorithms can actually optimize energy use, reduce peak loads, and balance user comfort with energy savings. Then we have strategies in which we look at user habits, and the system provide actually habit changing recommendation to users after gain data on their habits. Then we have user activity detection, in which the detection of users' activities actually helps to identify and deactivate unnecessary appliances. These systems monitor peak usage and propose energy efficient schedules. Finally, we have scenario-based energy consumption, in which the scenario-based energy management assigns specific rules to different energy usage scenarios. For example, we can have a scenario for comfort, one for economy, and one for emergency. So at this point, looking at appliances-oriented energy conservation strategies, we can have several different strategies. First of all, appliances curtailment, in which appliances are basically delayed or turned off when not in use from users or from schedule. Then we have the adoption of energy predictor, which is a predictor that can forecast appliances energy consumption in order to optimize smart home energy management during off-peak hours. After this, we have the identification of irrelevant appliances, which basically appliances that consume energy without user interaction are detected and turned off. After this, we have the adoption of appliances weight, in which weights are assigned to appliances based on user preferences. Secondly, we have appliances activity partner strategy, in which the system creates a classification of appliances consumption, enabling target energy saving action. Following, we have seasonal variation strategies, in which the system provides suggestion of adaptive conservation strategies based on user habits and on the specific season of the year. Following this, we have appliances classification, in which the system classify appliances based on their impact on energy conservation, and on this classification provides recommendation for the user. Finally, we have energy research scheduling, in which the system provides a schedule based on the optimization of energy use in order to enhance the integration of renewable energy sources and limit the use of energy from traditional grid. So, to conclude, the key takeaways from these lessons are that smart homes significantly reduce energy consumption and can enhance efficiency in our homes. Future innovation will regard the adoption of AI system, Internet of Things, and smart grids that will enhance even more this efficiency in our homes. And finally, the adoption of smart solutions can actually contribute to lower carbon emission in creating a sustainable future. Thank you for listening.